What's faster, a human goalkeeper's reflexes or a machine powered by artificial intelligence? Today, we're building a neural network powered goalie robot and putting it head to head against human reflexes. This is AI vision versus human reflexes. A professional goalkeeper reacts in about 200 milliseconds, but can AI beat that? In this video, we are testing whether a robot using computer vision and prediction can react faster than a human. Let's find out. The goal is simple: build a robot that can detect a ball, predict its trajectory, and block it in real time. Behind the scenes, this involves a neural network trained to recognize and track a moving object, allowing the system to react intelligently instead of just randomly moving. To make this work, we use a camera at the robot's eyes, a microcontroller or mini computer as its brain, motors and rails for fast side to side movement, and a solid frame to act as the goalkeeper body. Everything is assembled so the robot can quickly move left or right to block incoming shots. This is where the project becomes powerful. The neural network processes the camera feed in real time, detects the ball, and predicts where it will go. Instead of reacting after the shot, the robot calculates speed and direction to move before the ball even reaches the goal. Before it can perform well, the neural network needs training. We feed it hundreds or even thousands of images of a ball from different angles, speeds, and lighting conditions. Over time, it learns to recognize patterns and improve its accuracy, making its predictions faster and more reliable. Speed is everything in this challenge. We optimize the code and hardware to reduce delay using lightweight models and fast processing techniques. Every millisecond matters, so improving response time can be the difference between a save and a goal. To train the system properly, we first need data. We record multiple clips of a ball being kicked at different speeds, angles, and distances. This data set helps the AI understand real world scenarios instead of perfect lab conditions, making its performance more realistic. After building the robot, calibration is critical. We adjust the camera angle, align the movement range with the goal width, and fine tune detection zones. Without proper calibration, even the smartest AI can miss easy shots. In theory, the robot would struggle with fast shots, sudden direction changes, and imperfect lighting conditions. Without real world tuning, predictions may be slightly delayed, meaning the robot might miss more shots than expected. This shows that while the concept is strong, practical performance still needs improvement. Not every attempt is a success. Fast and predictable shots, poor lighting, or motion blur can confuse the system. Showing these failures helps us understand the limits of the robot and where improvements are needed. To compare fairly, we test a human goalkeeper against the robot. Humans rely on instinct, experience, and quick reflexes, while the robot depends on calculations and prediction. Watching them side by side shows the strengths of weaknesses of both. In the end, AI wins in reaction speed and consistency, while humans still dominate in adaptability and creativity. The comparison highlights how machines can outperform humans in specific tasks, but still lack the flexibility of human thinking. One important question is cost. This build can be done with affordable components like a basic camera, microcontroller, and motors, making it accessible for students and hobbyists who want to experiment with AI robotics. There is a lot of room for improvement. We could add faster processors, better cameras, or even train a more advanced neural network, future versions might predict curved shots or react in full 3D movement instead of just left and right. This project goes beyond just a fun experiment. Similar systems are used in sports analytics, autonomous vehicles, and security tracking. It shows how AI vision can react faster than humans in high speed environments. Even as a concept, this project shows how powerful AI vision can be when applied to real time problems. It highlights the growing role of neural networks in robotics and how they can push the limits of speed and precision beyond human capability in specific tasks. In a simulated environment, the robot shows promising results when tracking and reacting to straight, predictable shots. However, its performance drops when dealing with complex trajectories or sudden changes, suggesting that real world accuracy will depend heavily on further tuning and better models. One of the biggest challenges is reducing latency between detection and movement, improving camera quality, increasing processing speed, and using more advanced neural networks could significantly boost performance. With these upgrades, the robot could become much closer to competing with human reflex. In the battle between AI and humans, it's not about replacing people but enhancing what's possible. This goalie robot proves that when speed and prediction matter, AI can compete and sometimes win against human reflexes. Project is just the beginning. The same technology could be used in sports training, security systems, or even self-driving vehicles. If you want to see a more advanced version with faster AI and even better reflexes, make sure to like, subscribe, and comment next level goalie. See you in the next video.